Or there we go. Okay, we're live.
Cool.
And let me share now. Now I don't remember how to share. Where's my share?
Now it should be the
Okay.
bottom of the screen.
Yeah. Oh, there we go. Okay. I've done this so many times, but I still am not. Okay. You guys got the
Cool.
PPT now, right?
Yep.
Okay. So good morning, good evening, good afternoon. My name is Peter Rodenberg. I'm the International Admissions Assistant at SUNY Plattsburgh. I'm joined with Dr. Walters, the department or the head of the physics department, as well as some other colleagues around the world. Uh, Today, I'm going to talk about a few things about our university and then pass it along to Dr. Walters to discuss our robotics program here at SUNY Plattsburgh. The first thing I will talk about is kind of a welcome to Plattsburgh and talk about the area. Then our liberal arts foundation, we'll get into the academics here. Experiential learning, which we really push and take very seriously, and I'm sure Dr. Walters will mention that as well. We'll talk about some admissions requirements because students and parents are very concerned about what it takes to get here, and a few things to think about. And then at the end, we have questions and all that stuff. So SUNY Plattsburgh is a four-year accredited college located in northern New York. We're about 20 minutes from the Canadian border, about an hour from Montreal, Canada. It's a small, safe city, around 30,000 people. But although it's small, we have local amenities that you would need. We have an international airport, train station, hospital, places of worship. There's quite a bit of food and entertainment here. There's all sorts of restaurants from all over the world, right? There's a Himalayan restaurant, there's a Thai restaurant, there's Japanese restaurants, Chinese. It's a very global food community here.
It is.
There's something to eat for everyone. And we're a short walk from the downtown area. It's about 15-minute walk downtown. I walk to work most days. I live downtown, which is quite nice. There's also free shuttles to get students to the shopping malls and supermarkets and things like that. So it's very easy to get around. In addition, I mentioned the airport and train station. There's flights to Washington, New York. Does the airport go to New York, Dr. Walters?
I think it's Boston. I think it's Boston
To
and
Boston.
Washington. Yeah.
There's flights to some major cities. The train goes to New York, I know.
Yes.
We have buses that go there and all that. So it's easy to get around and convenient. It's cheap, not too bad. Well, why can't I switch my slide?
Okay.
There we go. So yeah, we're located in the north there. If you can see, there's a big lake. That's Lake Champlain. And Plattsburgh is on the banks of Lake Champlain. We're about an hour from Montreal, 4.5 hours from Boston, about 5 hours from New York City. So although we're a smaller rural place, it's easy to get to these major cities. We'll talk a little more about that a little later. It's a very beautiful environment here. We're in the Adirondacks Mountains on the banks of the lake. So particularly this time of year, actually about a couple of weeks ago was kind of the peak when all of the leaves turn different colors and it's like a postcard outside. It's really a beautiful place. And you know, if it's a smaller town, so I think it's easier to kind of get the studies done. And when you need to go to the big city and shop and party and do whatever it is you need to do, it's easy to do that too. So it's really a mix of the best of both worlds, in my opinion. And this combination of food and entertainment and history and environment and all that, it brings students from all over the world here, as well as faculty members and tourists, and it makes for a very diverse community. We've got about 5,000 students here on campus with over 300 international students from over 60 countries. So although we have 30,000 people in the population and 5,000 students, it is a very diverse area and diverse community. Your average US institution has less than 1% international students, and we have 6, which is very high. We take a lot of pride in the diversity that's going on here. It really enriches the community and the university and all of that. So we are a liberal arts college, and our motto is that we are centered on you as the individual. And you will see throughout SUNY Plattsburgh a focus on the student and the opportunity for one-on-one interaction, whether that's with your department chair, your professor, my office, your admissions people, your student support people, the career development center. Wherever you go in this university, you will find that there is opportunities for one-on-one interaction and building of relationships. And I'm going to mention this several times because to me, it's the most important thing when looking for a university is, can you get the one-on-one support you need? Can you build the relationships that you can carry over in your academic life and into your professional career? That the way I see it in my experiences, it's not what you know that's important, but who you know that's most important for moving on and taking that next step. And I am very confident that we can provide you with those opportunities here at our university. A little about majors. We have over 70 majors. These are a few of our more popular or interesting ones. Computer science and business management are probably our two most popular. Robotics is by far the most fascinating and entertaining and excellent major that we have here. And accounting, economics, biomedical sciences. We have many international students within these majors. And students will say, again, they'll say the same thing about all these majors, that the best part is the faculty, that the faculty is approachable and communicative, and they really get the support that they need. And in addition, you are more than a face in the crowd. When you go to a major university with 75,000 people or something, you are just a name and a number in a book. But our student to faculty ratio averages 16 to 1 here. That's 16 students to 1 faculty member. That's the average. To where your classes are not taught by a grad assistant in a big lecture hall with 200 individuals. All of our courses are taught by PhD professors. And you are able to build a relationship. So your professor knows your face, knows your name, knows where you're from, knows what you're good at, and most importantly, knows what you're not good at. So they can cater instruction to you and help you improve in the areas that you need improvement. When you go to a larger school with 200 classmates, you're a name and a number. And it's very difficult to get that instruction catered to you and to find time to build a relationship and to nurture that relationship with a professor. This really, there's a lot of important things when selecting a college, but to me, this is the most important one. How can you build relationships to carry on? And how can you get the support you need here at that moment? And that isn't just with the faculty either. I mean, for education advisement, like academic advisors, career development center, my office, wherever you go, there is that team environment and that family environment here where you can build relationships and get support. And I can't stress that enough, and I will stress it more as I continue talking. So in addition to that, experiential learning. I'll just touch on this because I'm sure Dr. Walters will mention this as well in a little more detail with his department. But we really stress the importance of getting your hands dirty and using what it is that you've learned. So you're in the lecture hall or you're in the classroom and you learn about theory and what it is that you're doing, but then you get to go and actually do what it is you've been taught, right? And if you're like me, you can read as many books as there are and still not really understand what it is you're learning. And you can listen to lectures all day long, but it's not until you actually do something that it really sets in your mind. And that's how I am. I wasn't a very good student, and I needed that opportunity to really use it, to really understand what it is, right? And we offer that. This can bridge the gap, as I mentioned. I think it's motivating to students. They get to do it, and it develops skills in real world setting. You work with your professor closely. You work with a team, I would imagine, in a lot of ways. I know and the robotics stuff, right? They have teams for the competitions and things like that. And, you know, you're working with other students to create a finished product. It gives you a look at the pros and cons of the career that you're considering before you actually jump into the career. And it'll enhance job opportunities and internship possibilities and things like that. I mean, the more experience you have in the field, that's going to transpose later in life, I would imagine. How do you do this? How do you get involved in this way? Well, you build relationships with your academic advisors, your department chairs, your professors, my office, and career advisors. You work with, you take advantage of the opportunities presented, and we can definitely give you these opportunities, and it's up to you what you do with them. So as far as admissions is concerned, I know this is also very important. The cost of attendance for 1 year, the average total bill is around $35,000. This cost includes tuition and fees, housing, food, health insurance, and unbilled things like books and cost of living every day and that kind of stuff. We have 2 scholarship packages, which, well, 3, I guess, that cover 20 to 40% of the total cost. The first 2 you can see here, the Global Diversity Award and the Campus Community Award, these kind of go together. These are guaranteed for all international students who come to our university. This is guaranteed for all of them. The additional scholarship, $6,000, is based on the students' high school transcripts and any standardized tests. So if you did really well in high school, and we are joined by a student here during our presentation, if you did very well in your courses and maybe your standardized tests, and let's say hypothetically you got a 1290 on your SAT, you would qualify for an additional $6,000 every year, which would bring the total to $13,500 scholarship. And we can give this to students every year. This is renewable, assuming that you keep high academic standards. You can't start getting C's and D's and then expect us to give you merit scholarships every year. So we expect you to keep high scores. And you know, the best way to keep high scores is to develop a relationship with your professor and to talk with them and get help when you needed it, right? And so after all of those scholarships, the cost of the total cost for 1 year is between $21,460 and $27,460, which is quite competitive for a school in the Northeast, especially a school in the Northeast where you can develop a relationship with your professor and advance your academic and professional goals. So a few things to think about. I always like to say this at the end of my talk, because I know that this is a very overwhelming experience. I've been in a lot of fairs recently, you know, where there's 100 different universities, and students jump into these fairs and they go into the booth and they don't know exactly what to ask, and they ask kind of simple, silly questions that really don't matter or that are very easy to find out already. And I think that what I come across is that students have trouble choosing a college because there are so many options, and it is overwhelming. So the first thing I would suggest to students is, what type of school? Are you looking for a public or a private school? A 2-year, a 4-year, or a community college? Each has its benefit. Find out what those benefits are. I think the most glaring one would be that a public school is considerably cheaper than a private school. There's other things in there. I'm not going to get into all that stuff, but I would, you know, consider that. Most students are looking for a 4-year bachelor's degree. The location is something to consider. If you have an uncle that lives in Chicago, maybe you would want to consider a school near Chicago. If you like a dry, arid climate, maybe New Mexico would be a place for you to go. If you like 4 seasons with mountains and a lake and a beautiful outdoor environment, Plattsburgh is a place for you. If you like the inner city with the hustle and bustle and chaos and high living expense, New York City is probably the place for you. So what kind of location is it that you're looking for? Uh, maybe the biggest one, the one to lead off when you're looking for a school is, does the school have your major? You know, I have a lot of students come into my booth and they start asking me all of these questions, and we spend 10 minutes talking, and then they ask me, oh, do you have, uh, uh, I don't know, mechanical engineering? Well, I'm sorry, we don't. We don't offer mechanical engineering. We offer robotics, but we don't offer mechanical engineering. So you could have saved yourself a lot of time if you let off with that major. Some universities don't have the major you're looking for. So that might be a way to start. Scholarship and cost, you know, some students, is it affordable to you? Right? I mean, is the price affordable? So ask questions about that in the beginning. Additionally, the cost of living. Students maybe don't consider that. One reason I accepted the job here in Plattsburgh was because the cost of living in Plattsburgh is pretty low. It's $20 in Plattsburgh goes a lot farther than $20 in New York City. And that's something to consider as well. I mean, because you want to live and have a social life and experience the culture and the surroundings, right? Is it affordable for you? And finally, the class environment, the campus environment. Are there sports and activities that you are interested in? And again, the student to teacher ratio. That's priceless. Can you build relationships to help you with the next step of your academic and professional journey? And that is something that our university can most certainly do. So with that, I'm going to pass it on to Dr. Walters here to talk a little bit about our robotics program. And just tell me when you want me to switch a slide.
That works. I appreciate you letting me come in and give a pitch for our program. Our robotics program is relatively new. We just instituted this 2 years ago officially. And this past May, we actually graduated our first 2 students from the program. What's neat is one of them went to graduate school. He has been accepted to University of Colorado. He's postponed it for 1 year because of COVID and wanting to have face-to-face classes versus doing remote classes in graduate school. And then another student of mine had a job offer. He ended up refusing it just because he didn't want to move to the area of the country where the job was being located. But it was good to see that people were interested in our majors coming out of this brand new program. So you can go ahead and go to the next slide. What's neat about our program is it is a combination of the computer science department and the physics department. We work together to mold our students or give our students the opportunities to learn both the hardware and the software side of robotics, because robotics is one of those weird majors where you have to be able to do both pieces at least somewhat to be a good roboticist. But we do allow you to concentrate. So if you're majoring in robotics, eventually you'll decide whether you're going to major more in the hardware side of things or the software side of things. And what that really means is you're going to be, and we'll talk about this in another couple slides, but it means you're going to take more courses in that focus. But that being said, you still will have courses on the other side. You are still going to have, if you're a software person, you're still going to have to take a couple hardware courses. And if you're a hardware person, you're going to have to take a couple software courses. So it makes it a very malleable major. And we also have minors. So in case we had to worry about, I have sometimes somebody wants to be a physicist and a robotics major, or somebody might be a biologist and a robotics minor, and they can still get that flavor of robotics. So because biorobotics is a really cool field right now, where they're trying to either emulate biological systems or trying to marry robotics with biological systems. It's a neat combination. So we give opportunities for that. Next slide, please. So the major is actually credit intensive. Most of our majors at SUNY Plattsburgh are in the 45 to 50 credit range. You'll notice that this is a lot higher than that. And that's because robotics is such a broad field that we have to give you that basis, that foundation to stand upon to go farther in life. So it is a rather intensive field. The general education requirements, that's part of us being a liberal arts institution. We want you to have this well-rounded viewpoint on the world. So we will make you take classes in sociology, in history, in humanities, and there's a few other ones, and there's a whole new version of this coming soon. But anyhow, we still want you to be a well-rounded individual. Then there's the Robotics Core requirements. These are where you are going to get some hands-on learning, and we got a slide coming up about that specifically. But this is where you get your start of what it is to be a roboticist. And then, like I said before, we have our specialization. So you're going to take 5 courses in your specialization, whether it's going to be in the hardware or in the software. But you're going to take 2 courses on the other side. So you're going to get 7 courses that you sort of tailor yourself to be the type of roboticist that you wish to be. And then there's some applied learning electives, which are some of the more exciting courses in the major, and we'll talk a lot more about them in a second. So like I said, the nuts and bolts of this is 67, 79 credits, but there still is room in there. So if you did want a double major or have another minor, you can do so. But just keep that in mind that you don't have a lot of wiggle room, so you can't come to me in your junior year and say, third year and say, I'd like to add a biology major. We could have a little problems here. But if you came in day one, yeah, go ahead.
Yeah, so it would be advantageous to create kind of a plan here your first year or two, right?
And that's where it's great, because you do meet with your advisor twice a year. I mean, twice a year, once each semester. And that's so you come in and say, hey, Dr. Walters, I want to do these 2 things together. We can map out something for you, especially early on in your career. And it makes it very customizable. It's just that we have to have some preparation to be able to do this because of the intensity of the robotics major.
Yeah.
That being said, there is a lot of coolness built into this major, and we'll go over some of this now. You go to the next slide.
A lot of coolness.
A lot of coolness. All right, so this is my robotics core. This is like the stuff that everybody who's in a robotics major has to take. So there's a lot of math, because we got to be able to do math, some physics, some programming languages. Our primary 2 programming languages we deal with in robotics here is Python and C++ as well, but whatever flavor of C you want to do. But those are the main 2 languages we use. That's not to say that there aren't other languages that we could pull out, but in your 4-year career, you'll be dealing quite a bit in C and Python. We also have a course in ethics, and that's an important course to take. Robotics can be controversial. You know, we think of it as engineers and as scientists, like, what's wrong with a robot? But you know, we're coming to an age where if what roboticists do in the future is help remove humanity from having to do manual labor, that sounds all well and good, except for all the humanity that does manual labor.
Yeah.
And so we have to be looking at this ethically as we move forward. What does it mean when we make these new inventions and we come up with ways to make people's lives easier? What are we doing to the population that used to do that? And how do we help transition people to other careers? But it is our job as roboticists, because we're the ones pushing forward with this new future that people want. I mean, it's not like we're forcing anybody to do anything, but we do whatever we come up with does have ramifications. So we just have to keep that in mind. So we do have a course in ethics that you have to take. And let's see, we'll go to the next slide, because I think the next slide has what I was going to hit. All right, so let's say you wanted to be the software version of robotics. Here are some of the courses you would take here. So you would have discrete math, and that's just a way for us to talk about when you have logic, how does logic work? That's what discrete math is all about. So how do you set up logical statements like this and this, or this or this? What does this really mean? Learning how to program well for data structures. What are traditional ways of doing programming such that somebody else can pick up your program and take a look at it? That's important. Then you get the fun things like, embedded systems. An embedded system, let's see, I actually have, yeah, I do. One second. Here's a little robot. This is a Zumo. It's one of the robots we can play with in the college. And what it has built in there is a little microcontroller. Well, we can program that microcontroller on the hardware side at basically like a 30,000 foot level, right? We know some ways to get in there and make the robot do the things we want it to do. When you take embedded systems, you can zoom right in and handle that at ground level. You know how to individually turn different things on and off in the robot and manipulate those. And so the embedded systems is a neat course because it really gets you down to the nitty gritty of how the hardware interacts with the software. You're not what they call abstracting. You're not abstracting anything. You're really right there at the fundamentals. Artificial intelligence. It's fun to play with artificial intelligence. It's frustrating to play with artificial intelligence, and it's the future. So there's the 3 Fs: fun, frustrating, and the future. Mm-hmm. But so you can take a course in artificial intelligence, distributed autonomous systems. How does this whole world work right now? It's distributed autonomous systems. You have the thing called the cloud. What is the cloud? The cloud is a distributed computer network where there's a CPU who's not being used right now at Google, because Google's got thousands of millions, almost millions of computers sitting around doing things. And so you go ahead and say, I need to use part of the cloud. Google goes, here's a piece of computer hardware, go use it. It's all distributed, it's all autonomous. So we teach you about that. And image processing. That one's fun because the image processing is a way to, how does our hardware interact with our world? We interact mostly with our world with our eyes, and then we manipulate from there. So we naturally will gravitate towards how do you get a computer to interact with the world with its eyes. And what does it mean by eyes? And there's a lot of different ways we can talk about that. And we probably will catch some of them in a second. So we go to the next slide. On the hardware side, I screwed up the slide. All right, well, that's okay. We can talk about it. That picture's a little bit in the wrong spot. So on the hardware side, we deal with design. How do you design something, especially in an environment of other engineers or scientists? Because we have to try to come up with ways to differentiate. I tell my students when they take this course, you have to learn how to handle your pride. We get so used to when we come up with this idea, it's our idea. Ooh, this is great. And you throw it out in a room with a bunch of engineers, and they'll be like, your idea stinks. And this is why your idea stinks, and come up with various ideas. And here's a better idea. You have to, up until that point, we're told our ideas are basically us. You know, oh, that's such a great idea. You did such a great job. Now it's more the idea has to live on its own. And because of that, you have to realize that when somebody attacks your idea, it's because they're looking at the merits of your idea, not the merits of you. And for some students, that's a real issue. And so they have to learn how they can criticize other ideas without criticizing other people. And then how do we come up with a framework to do that criticism in a ethical and in a more scientific way? And we want to make it such that there's a reason behind it. Maybe it's because of the cost of the idea. It's a great idea, but it would cost $2 million. We're putting out widgets that cost 50 cents. Well, it doesn't make any sense to do the $2 million idea. Or it could be because one of the most important things is the usability, the end usability to the user, and it's lacking in that aspect. So we have to come up with ways to framework our discussions and our arguments for cons. So an engineering design. So not only do you learn how to design a product, but you learn how to interact in a professional environment. And a lot of stuff there that I wish I had known when I was in industry. I was in industry for 10 years before coming back to teaching. This course is basically everything I wish I knew before I went into industry. Because when you go to industry, you're in a meeting and all of a sudden this stuff starts happening. You're like, what just happened? Wait, slow down. We hopefully get you more up to speed for that. We give you 2 electronics courses because let's face it, this is built out of electronics. So we give you an introduction, which is electronics for scientists. We talk with digital and analog systems. So we get both sides of the house. And then we have an advanced digital design where we really hammer, no kidding, this is the digital side of things. We have a controls engineering program, not program, but controls engineering course, because we have to know how do we control these things. There are certain laws in mathematics that are behind control systems. And so we teach you how to model these control systems and hopefully implement them. And last one, robotics, kinematics, and dynamics. Basically, what the picture is down there is a robotic arm. And we teach you how to do the math behind controlling robotic arms. What's funny is it seems really simple until you start getting into the math and you go, oh my goodness, it's a lot harder than I thought it was. And a lot of it isn't necessarily the difficulty, but we are really good at mapping out things in 2 dimensions. Robotic arms have 3 dimensions with rotation joints and movement, and you're just going, wait, if I do this, oh wait, that changes. Matter of fact, I print my students these little, I don't have one here, unfortunately, these little devices that just have 3 pointers. And you'll see them take it up and they'll pick it up and then they'll rotate it and turn it and do just to see where their end's going to be. So we try to get you to start thinking in 3-dimensional space because your robot's in 3-dimensional space. Okay, next slide. In case you can't tell, I teach a lot more of the hardware side than the software side. This is the core. This is my 4 horsemen of the robotics program right here. This is what is exciting. Each year, you will get to do an experiential course. We will get you hands-on with hardware. Matter of fact, you don't even, yeah, other than physical computing, I don't even think for physical computing, we have a textbook for any of these levels of course. Your textbook is the hardware you will be using. So in the freshman year, physical computing, you are going to be using, I brought some show and tell. I almost dropped my show and tell. You'll be using one of these. This is an Arduino. It's a microcontroller, okay? And the neat thing about these guys is once you get them programmed correctly, they're bulletproof. That's what we love about them. You just have to get them programmed correctly to get them to the bulletproof. So you get some exposure in your very first year, how to like turn on LEDs, use buttons, make motors move. Sometimes some people are like, well, that's very simple. Yes, it is, but until everybody has that same level of expertise, it doesn't make sense to go to the next level. We try to make you ready for that next level after year 1. Year 2, you get the introduction to robotics. That's my course. So when I teach that course, I warn my students the very first day. I go, you're about to embark on the craziest course you will get on here. And the reason for it is it's an introduction course. Introduction courses are usually very wide in the amount of topics they talk about, but very shallow because they're usually the 100-level courses. You get a little taste, like in physics, where my background is. You get a little bit of energy. You get a little bit of kinematics. You get a little bit of this and that and the other thing. Almost like a smorgasbord, okay? You go out to dinner and it's like a buffet. You get a little bit of everything to try it out. That's what an introductory course is. You'll notice this is an introductory course at a 300 level. That means it's a junior level, 3rd year course. So that depth is really much more than a regular introductory course. And so I warn my students, I go, this is one course where you are going to be constantly pushing it. We talk about everything on those previous slides. We talk about it in Introduction to Robotics. So we hit everything there. So when you're ready to go to that next level, that next course, you've had a good foundation for those courses. So we do artificial intelligence. We don't do as much embedded systems because that is a specialty. But we do all these different pieces along the way such that when you get to those other courses, you're ready to go. And you get to play with Kif. There's a picture of Kif coming up, but I'll show you Kif. I unfortunately don't have him put together again. This is the robot. This is going to be, that's your textbook for the 2nd level. And you put this together and you program it and Kif moves around and does neat things, hopefully. Or if you ask my students right now, they're doing a task where they have to move Kif around on a table. I give them random movements and then the Kif has to tell them where it exists. And they're not enjoying that right now. Because it's not as easy as they were hoping it was going to be. That's year 2. Year 3, you get the intermediate robotics lab. This is another fun course I'm teaching currently. You come in, you're in a team because we have to get used to working in teams. This is what industry does quite a bit is you're going to be working on a team on a project. And so I give you a project that you can't Google. It doesn't exist. I check. But your job is to, by the end of the semester, have the robot do the thing we did. It was the challenge. Now, could you Google individual pieces? Yes, and that's the whole beauty of it. You start learning how to, what's called synthesize information. Take the different pieces of information out there and weave them together into a cohesive answer to the problem. So this year I have 2 projects I've been dealing with. One was I give my students a map. Now the map is a very simple map. It's not like a complex map that you would see from what we were shown before, where the map of like Plattsburgh, where it is in New York State. My map, I have a pentagon of a certain color. And attached to this pentagon are different straight lines, and eventually they go through different circles of other colors. So what could happen is whatever color the pentagon is, you have to find the circle of that appropriate color, and then you can only move on black lines and the colored lines of the pentagon. So if there's other colored lines on there that aren't the color of the pentagon, you have to throw them away. So the robot takes a picture of the map, figures out the shortest path between the pentagon and the circle, and then it has to drive on my floor from the pentagon to the circle without any other sensors. And that's a difficult task, but it's very doable. You break it up into chunks, and actually they're about 3/4 of the way through that process. Another one, I'm having them follow a road. We built roads out of tape, and they're following a road. And when they reach an obstacle of the road, they have to identify what color the obstacle is. If the color of the obstacle is green or yellow, they have to pass to the right of the obstacle. If it's blue or red, they have to pass to the left of the obstacle. The color of the obstacle tells it what color road they have to pick up on the other side of the obstacle to go to the next obstacle. And so they're constantly doing this refreshing, and they have a distance sensor because they can't get too far away from the obstacle or else they fail. So they're now using all these different sensors and trying to figure out, once again, synthesize that information to understand how to drive around this obstacle to get back to the road, keep driving. And what's neat is they've actually changed how I thought they were going to do it one way, and they've totally thrown that away. They figured out a new way to do it, and they're running with this total vision system instead of using some sensors that I thought they were going to use. And that's exciting for me. I like seeing that. We encourage, if you can think outside the box and come up with a solution, do it.
Yeah.
I found a simpler solution, but they're trying a more expensive one, and it's working. And that's the key. So, like experiential, you do it. Now, the final project for everybody at the end of intermediate robotics is you have to decide what your final project will be in terms of senior level projects. So you see seniors robotics project. That one is your project, individual. So you will sit down with the advisor and write up, okay, I want to do, so previous projects I've had, I had a student who wanted to find dogs in his webcam. So he wanted to be able to put his webcam outside and know when his dogs were in his backyard or not. And it sounds simple. It's not as simple as it could be because, how do you process the information? How do you keep what's there, getting timestamps? So that was his senior project. He wasn't as successful as I was hoping he was going to be, but he did okay. Another student wanted to take a robotic arm, attach sensors to his body, and use his arm to control the robotic arm. And the neat thing about that, to challenge himself, he used sensors that were medical grade, like if they're doing, oops, sorry, that was Alexa trying to do something. He wanted to build it, so what he was trying to do was he used sensors that you could use like for an EKG, where they're looking at muscle tensions. He used some of those sensors. He used accelerometers. He used accelerometers, sensors, and gyroscopes on his body to try to map it out. So it wasn't just one type of sensor. He wanted to use multiple types to be able to show that he had some mastery of all these different types of sensors. And his goal was to pick up a pen and sign his name with his robot. He couldn't sign his name. He found out that was really, really, really difficult, especially with the robot we had, the arm. But he was able to pick up a pen and make a mark on the paper. That was good. So that was his senior project. That senior project is yours. So you spend one of your senior semesters 12 hours a week working on your project. And the greatest thing about this is then when you go to a job interview and they'll say, well, what did you do in robotics? Oh, let me tell you what I did in robotics. My project was X. We went ahead. These are the problems I figured out from this thing. These are the ways I attacked those problems. Here's where I failed on some of those problems, but then I came up with different ways to do it. And employers love that because they can see how you actually attack a problem.
Mm-hmm.
One of the best job interviews I ever gave was when I was talking about a system that I had to build from scratch in a very short period of time because of a customer issue. Whenever I tell that story, every employer will sit there captivated for the next 15, 20 minutes. I have them tell the whole story. And that's great for job interviews because once again, we get all nervous, right? We're going in, we're about to be judged by people and we really want to get this job. If you can take control of the interview and talk about something you're passionate about and they see that, they're captivated. Now they're captured by you for the next 20 minutes and you control the conversation and you know what your experiences are. So that's awesome. I'll show you why there's more about this in a minute. So these are our experiential courses. This is so important to get your hands on, especially with robotics. You need to get the things to work because the ideas, the concepts are simple. What's a line follower? Oh, that's not too bad. Well, you know what? I can give you a line follower that's really horrific to try to program. And I will, because I'm a nice guy that way. but you go from a very simple concept that middle school students do, and I can show you a path that a middle school student's line follower cannot follow. Now you have to create the line follower to do that. And I'll give you the skills to do that, but you have to do it. And so you really get the hands-on needs and understanding that you can't get through a book. You just can't. Next slide, please. So here's a better picture of KIF. KIF changes every year. I'm still changing KIF up. Next year, KIF is going to be a little bit different. So the two big pieces of KIF, you can see it on the middle slide. On the left-hand side is the Arduino, just like we said before. There's a camera. The middle part there is actually a laser rangefinder. So we use lasers to sometimes find our how far we are away from objects. On the right-hand side picture, down below in that sort of cubby, that's a Raspberry Pi. That's the brains of our robot. The Arduino's Raspberry Pis of Adafruit feathers. There's a couple of feather lights. There's a couple other types out there. This is the reason why we can do robotics in Plattsburgh. Up until about 5 years ago, 10 years ago, hardware to run a robotics lab would cost upwards of $1 million to $10 million. And universities aren't going to let undergraduate students play in a $10 million lab. It just isn't going to happen. But because the hardware has gotten cheap enough, we can make it so you buy this. I mean, it's really cheap, but it works very well for teaching basic robotics principles. The only difference between this and the fancy hardware is the fancy hardware is more reliable. Well, you know what? That's good. You learn on the hardware that's not as reliable. You learn tricks of the trade that way. So when you get to the reliable hardware, it's so much nicer when I actually program this and it does it the first time. I don't have to go ahead and mess around with it and really narrow down what I'm doing. So you get better experience, in my opinion, with the less reliable hardware because you learn how to do things. Now, your frustration level goes up because you're using the less reliable hardware. But that's okay. We build this into the system. Don't think that we're setting you up for failure. We really do build into the system the issues you're going to run to. But that's KIF. Now, if we go to the next slide, you'll see a picture of our robotic arm. So we do have robotic arms that you can use. This is the one actually that Almus programmed with his body. So it's, let's see, 1, 2, 3, 4. It's a 4 degree of freedom arm. So you could do almost anything you want to with that arm because you need 4 degrees of freedom to be able to do most things. And what's great about it, since it's smaller, you could really go at it. If you had a way you want to modify an arm, we could do that because it's not this $10 million arm that I can't let you use because it's too expensive and I'm worried about you hurting yourself. It's more of, here, look, you can see the control board is exposed right there at the far end. Go ahead. We can put a different control board on it. We could try, if let's say a student wanted to develop their own control software, maybe that is what they want to do as their senior project. Okay, there it is. Go at it. Let's see what you can do. So we have these opportunities. That's the biggest thing, is you have these opportunities to get your hands in on it, to get your hands dirty. And we force you to do it in some aspects, and we encourage you highly in all aspects to get to do this. Now, if we go to the next slide, I think this is an important one. We take our students out most of the time, except right now in COVID. We take our students out to actually compete. Now, competition isn't for everybody, and I totally get that because some people don't want to have that pressure of competition. What I love about doing competitions, though, especially in groups of teams, is that you get to see how much you really do know on challenges that you aren't necessarily going to get at the school. So this is my team that went out not this past year, but the year before. Now this past year we weren't able to go because of COVID, but this is my team that I took out the year before. And what's great about this competition is we built, let's say we have an autonomous remote control car. It can do about 60 miles an hour. So that'll be 90 kilometers per hour roughly. So it can move. It travels quickly.
Yeah.
And our job was to try to program this thing to go around a course outside without us controlling it. And so my team there, the students, built that. They developed it. It worked really well at slow speeds. When we tried to speed it up, it didn't work as well. So the next team that takes over that project will now take and build upon that to help enhance that, and you learn even more about doing autonomous robots. There was an Internet of Things challenge. That's what's the right-hand side, is the Internet of Things challenge. And our team for the Internet of Things was trying to figure out how to make it such that temperature sensors and I think there was a position sensor there too, working distributed around the site where the competition would be held. Could you interact with those across the internet? Because that is going to be the next thing for robotics. Can you, interact with your robot across vast distances? So they're doing some of that at this competition. We get our hands on. That's the key. We get our hands on, we get to apply it, and we get to use it. So in the next slide is one of our ultimate things. There was a NASA, National Space Aeronautics here in the US, had a competition where we had to build an autonomous rover. So we built a robot that would drive into a football field, a pitch, and find a purple rock and a piece of PVC pipe. Once again, you can't Google that. It doesn't exist. So we had to build it from scratch. Now this competition was neat because I actually got to join my students to do it because it was open to anybody. So we were all working together with this. And so we built what we called lovingly the Redneck Rover. And redneck just means it was, there's nothing fancy about this robot. What you're seeing here is something built on plywood using PVC pipe, cardboard, 3D printed parts. But the cool thing was my students designed it from the ground up. Mm. They built everything you see there. They developed challenges that were all of a sudden like, oh, we're trying to do. So the big PVC pipe you see there, the green thing that's up and down, we had to be able to pick up the rock. Before we came up with this idea of this PVC pipe, we were trying to come up with like a regular hand, right? You would have this hand come out, grab the rock, bring it back. We had never built an arm before. So how are we going to do that? We're sitting there, can't come up with something. All of a sudden, my student had this brilliant idea. Instead of building in hand, why don't we build like a big 3D printer? So this is like a 3D printer. It has a platform that moves up and down, left and right, and can move vertically. And that orange ring you see, let's see, I think I have the pieces here. No, yeah, I don't have it with me. I'm sorry. That orange piece there ended up being our hand. So we were trying to figure out how do you pick up a rock? We don't have a gripper. How do we pick up a rock? And in my office, we're sitting there. Jordan was sitting in my office one day, and the person who was the chair of the physics department comes in. Says, too bad you couldn't use an iris because he was a photographer. And when you open and close the shutter of a camera, that's an iris. And it basically closes and opens to limit light or to open it fully up to let the light in. And he said, that'd be great for picking up stuff. But the problem with an iris, a metal iris, is if you get a little dirt in there, when you try to close it, it jams. You can't close it all the way. So that won't work. And then a couple days later, Jordan comes in my office. He goes, I figured it out. We'll make an iris out of rubber bands. What? What? Iris out of rubber bands? He's like, no, dude, it'll work. Trust me. I'm like, okay, go make me a prototype. So we went to the lab, and like 15 minutes later, he comes back out. He has a box that has holes in it. They tied rubber bands to, and inside the box, he cut a big hole out. He put another ring inside that where he tied rubber bands. So he's like, look, put your hand in there. So I put my hand in there. He spins the inner ring, and the rubber bands rotate around your hand and clamp down on it. And you can move it up and down, and it sticks right there. And he's like, look, this works.
That is awesome.
Oh, and I'm like, yes, let's do this. So we built a rubber band end effector. And what's funny about that rubber band end effector is it could lift heavy objects. At the same time, it was very gentle.
Yeah.
Now, how we proved it was very gentle scared the crap out of me. I'll be honest with you. I look over and Jordan's like, hey, look at this, Dr. Walters. I look over and he presses the button. He had his hand up inside that tube. And you hear it go, I'm like, what are you doing? It's like, see, it's fine. He starts pulling his hand up and down to show he's not getting hurt. I'm like, that's awesome. And never, ever do that again.
Yeah.
So what Jordan said to me, and I pass this on anytime I give a talk, building this rover was everything in his education put into one thing. And that's important. You really get to see why you're learning the things. We look at so many things where we're being taught, and you sit there and go, why do I care about this? What is the reason behind this? When you could do things like this, and this is what I love about these competitions, when you could do things like this, it brings everything home. Oh, this is why we do this. This is why you taught me this. And it was great. Now, I will be honest with you, we failed miserably at the competition. And it wasn't because our rover didn't do as well. Our rover could do all the pieces it needed to do, but we learned one very important, well, we learned two lessons, but the major lesson we learned was we had to work on communication better, not between our teammates, but the different systems of the robot didn't talk to each other as well as they needed to. And so there was always a breakdown of communication such that a robot would do half the things it needed to do and then just stop because communication broke down. And all of a sudden the robot didn't know what to do because the brains are saying, let me know when you're done. And the other part would be like, I'm done. And the brains are like, let me know. I'm done. Yeah, let me know. And you're sitting there going, wait, why are you not communicating with each other? Because when it did communicate, it worked. But we learned that only because we built this. And we learned how to do more robust communication systems after that because we built this. Unfortunately, it didn't help us for that competition. But so to give you an idea, we still do competitions. So the last slide we have, if you go ahead and go to that, is this was a virtual robotics competition. So we had a raw server that stands for Robotic Operating System. We have one of those on campus. And what you're seeing is a lunar surface. And our rover, which is the little thing, the little buggy there you see sort of in the lower right-hand corner, was supposed to go around the lunar surface finding minerals and other gaseous ices and map out the surface so we knew where the resources were. So when humanity gets there again, you could go straight there to get whatever resources you needed. It was a virtual competition. Unfortunately for us, just as we're getting started is when COVID hit. So we got started on the competition, and because my students then had to scatter to wherever parts of the world they were from, even though it's remote, it was hard to organize at that point, and we did not actually put in a solution for it. We're hoping that if they do bring it back, we will be able to do so. We were starting to make progress. We knew how to, so in this type of competition, once again, how do you move a rover on the lunar surface virtually? How do you use the sensors on the rover? We had finally, once again, gotten started in those positions. We knew how to run our sensors. We knew how to move the rover around. We were starting to learn the pieces we needed to learn when it got shut down. So until you get to experience this, see, that's the thing. Get out there, do the experiential thing. Get your virtual hands dirty in this aspect.
Yeah.
You start seeing how these different pieces go together, and all of a sudden realizing one of the things that surprised me was how much you slip on the moon, because they modeled this physically like what it is on the moon, and that rover slips. So you'd be driving up a hole in the ground. You're coming up through a crater, and you want to stop because there's some stuff here you want to look at. So you drive up, and all of a sudden your rover goes, starts coming back down, and you're like, wait, stop, don't do that. But it's because you had to realize that you had to come up and sort of come at an angle to try to keep it from zooming back. All these cool things, but we didn't know them until we started programming them.
Yeah.
So keep that in mind. So that's the exciting thing about the robotics program, in my opinion, is not only do you get the pieces, the academic side, you will get opportunities to apply your education, and that's important.
Yep.
And I think I blabbered enough.
Well, I think it's really cool when you talked about putting the rover together and using all 4 years, all 4 years of theory and things that you've learned and putting them all into one project. That's fascinating. And I think it must be very eye-opening for students, not only to draw the connection between the things that you learned in the 4 years, but to find, you know, that chink in the armor maybe that you're not so good at, you know.
Yep.
Like I'm good at A, B, and C, but D I'm not so confident on, and I can see that now because I put this whole thing together, right?
Exactly.
Yeah, that's pretty cool.
And those weird connections you make, because there's times where, even so, when I was telling you about the map, my students could change the map around, get the pieces, but how do you go from beginning to end? And even I was sitting there because when I give you those problems, since I can't Google them, I don't have all solutions either in the very beginning.
Yeah.
I just know there should be a path.
Yeah.
And we were sitting there one day trying to brainstorm the piece that I didn't know about. And all of a sudden we look at each other like, wait, that's wavefront planner. That's something I teach in Introduction to Robotics. And it's like, oh, wait, well, you could apply that to here.
Yeah.
All of a sudden it's like, all of us, a light bulb went on. Oh, well, this is easy now. But we didn't know that at the time. They're like, this is a problem. How do you get from point A to point B in this map? Oh, crap. And it wasn't straight lines. There's some curves. How do you do this? And as soon as we said, wait, this is wavefront planner. Oh,
right.
Oh, and I'm like, you see, this is why I teach you these things, because this way you have this bucket of tools that you don't know when you need to pull them out.
Yeah. Yeah. That's awesome. Well, thank you, Dr. Walters, for this informative robotics lesson. When I end the presentations, I always give my contact information.
I can do the same.
Everybody has that, I think, here that's in this call. There's one other additional thing that we have now that it's brand new. But Bina, I don't know if you're familiar with this program or not, but we have an option now where students can chat with our current students.
Okay.
And I put a link down on the bottom, and I can send you this PPT as well.
Yeah, I think that would be great. Yeah, I think that would be great.
Especially with the admissions information and things like that. I know that can help you in the future. But this link here on the bottom, students can go here, and this is a screenshot of our webpage. And on the right there, it says chat with our ambassadors. And we have students from all over the world that anyone can come on and, you know, start a conversation with them, where they can talk about anything, you know, student life or clubs or majors or what have you. There's also, you can see on the top, there's a staff option, which you can talk to myself. There's a blog option where we're going to have students putting blogs about life in Plattsburgh and things like that. So it's really an interesting way, I think, for students to, you know, get feedback from their peers that are already going through the process. Enrolled, and and I think it would help, you know, alleviate some concerns and answer some questions. And I think today's generation is very interested in this type of communication. So this is something we just launched it 2 days ago. So we're really excited about it. But yeah, I'll send this information to you as well. And I would really recommend sharing this with your students to give them an idea of what it's really like to go to school in the United States.
Actually study there,
To study there, yeah.
And I put my email in the chat, so if somebody wants to email me, feel free to give it out to do something. I mean, if they have questions about robotics or whatever, that would be a great thing.
Absolutely. And our student here, Tulsi, will be joining you in robotics. So she may have some questions here in the future. I don't know.
I do have a few. Yes, please go ahead, Tulsi.
Yeah. I actually have zero-hand experience in electronics. So should I be doing some things like before coming there?
To be honest with you, you
I'm
can
a
get all the
computer science student.
Okay, good. Because let's say the biggest thing would be if you can get math. Math is like universal. You could do that, and that will help a ton. If you get pre-calculus out of the way, you're ready to go. We'll give you all the electronics. It's not a problem. But the biggest thing is getting that math, because that makes it easy. You could get through the robotics program without having pre-calc before coming, but it's a little bit harder. It delays a couple of the steps along the way. If you get calculus, it's even better. But really, pre-calc, coming with pre-calc is good. It's very good.
And I would add to any student who's looking at this video now, that's an excellent question before you come to the university, is to get in touch with your department chairs or any of the professors in your major and ask them that question. What is it that I can do to prepare myself for this field, or for this major, and before I come to Plattsburgh? Yeah, that's a great question. And I don't hear that question very often.
Really? That's surprising.
But I mean, I'm not involved in the major, so I always push them to you or to other people. I say, look, I don't know if they contact you or not. I give them the contact info. What they do with that, I don't know. So, yeah, but that's a great question.
In fact, that was one of the things that I had in mind. I must tell you, Dr. Walters, you sound so passionate about the subject that you were speaking. And more than that, there was so much fun that you really enjoy what you are teaching your children and the kind of projects you're doing. There was so much of fun on your face. You're really excited about that. And I think that's what I think students need to get when they're actually studying.
Yeah.
To have fun while they are really learning something.
Yeah, absolutely.
That's the goal, because if you...
You're cutting out. The joys of Zoom.
But by the way, if you wanted to get an Arduino and just play around with it, you could. I'm not saying that it's a bad thing or a good thing. It just, this is when somebody else was talking, somebody was asking me, I was doing an open house for US students, and they were asking me the same question. So I told them the same answer. And I said, also, if you get one of these, they're usually pretty cheap. I mean, so in US dollars, this is 15. You can get ones, the smaller ones, for like 7. So I don't know how that translates money-wise across, but they can be fun to play with on their own. And it never hurts to have a little more knowledge in your pocket. You're going to learn new things when you're here. So give you an idea. I was teaching how to use a button one way with these, okay? And I'm like, okay, this is how you use a button, this is how you use a button. And then my students took that physical computing course. They go, Dr. Walters, they don't use it that way. They use it this way. And I look, I'm like, I never knew you could do that. And so this is why you might bring something to me that I don't know because you played around and go, well, Dr. Walters, this makes much more sense to do it this way.
Vina, you're back.
And you're muted, just so
but
you know.
You're muted.
Yeah. So my basic question was, what are the subjects that the students should come with? What are, like, for example, in our batch, the students are studying math. They are studying, many of them are studying computer science. They're studying physics. So is that enough a requirement, or is there any other requirement? Like you mentioned, math is one of the areas that they need to.
That's usually the place that I see the most hiccups. So we will teach. So if you have pre-calc, you'll take calculus, physics, and let's see, calculus, physics. Usually there's some kind of English course, some writing course, because once again, that's part of the liberal arts side of things, and a programming course in that first semester to 2 semesters. That's going to be the big focus of those courses. And then from there, you start getting into the major. So physical computing, actually, so the very first semester you come, you'll be in physical computing. Because it's like literally, no, you come, there you are. Do something with robotics. And we built that purposely. When I was going to go to college, I was going to be an engineer. That was my initial starting point. By the way, the joke also I told my students, plan on changing your major, changing your life a few times.
Yes.
I started off as an engineering major, became a physicist, got a PhD in physics, was an engineer in the industry for 10 years, came back as a physicist, now I'm a roboticist. I'm 50 years old. I don't know what I'm going to do next. I got to come up with something in about 10 years because it seems like I do about 10 years and get bored with it and go to the next thing. So we'll see what that next 10 years.
I have a very similar story. I have a very similar story. Yeah, that's very true.
And students are surprised by that because they think, oh, well, this is just like a monolithic path. No, it's not.
No.
When people take my introduction to robotics, remember I said it's very deep and very wide? I've had students come into that course thinking they want to be roboticists. 3/4 of the way through the course, they're like, I'll make it through. I never want to do a robot ever again. I'm like, that's okay. You found this out in your sophomore year. That's a very good thing.
Yeah.
Let's now find what you're passionate about and get you in there.
Yep. Which is the benefits of a liberal arts school.
Yes.
As well.
And the passion thing that you pointed out is important because when you hit that wall, if you have passion, you're going to figure out how to go through the wall, over the wall, around the wall. You'll find a way past the wall. If you don't have passion for it, you hit the wall, you're like, okay, what other direction can I go? That hurt.
Yeah. Yeah. So, and Bina, I'm going to add a little to that answer for your question is like, as an admissions officer, right? As someone who's looking at, international students come to us and they say, I want to study whatever it is. And we look at your transcripts, right? Your high school transcripts to determine your GPA is high enough. So one thing that we would look at is if you were looking to choose a major in the STEM field, we would need to look and make sure that you had math classes, science classes, things like that. That's really, that's one thing that we would look at in your transcript to make sure. If you didn't have, if you wanted to study physics, but you don't have many science or math courses, that's a red flag for us. And we would say, wait a minute, you probably shouldn't enter as that major. Now, you could change your major when you get here. That's absolutely doable. But when you enter, we would question that connection there.
Right.
We want to see success.
We want to see success.
Students thrive, and that's the thing. Don't put them in.
Again, I'm asking this question more as somebody who has very little knowledge about robotics as a field. As an outsider, I have this perception about robotics that it is a research-based field, and it requires people to pursue higher studies. Or is it something that's more practical and can provide students with job opportunities even after undergrad?
Yes, nowadays it's coming down because of that. Because it's becoming more ubiquitous. Before, robots had to be these really fancy machines. And now you think about, there's now thermostats that you can buy that are roboticized. There are all these little Roombas. You can make a Roomba that vacuums your house that's a robot. There's enough of it coming down. Not only that, but I find students, so the one student who got a job offer, he was going to get a job it was basically a computer science job, but it was dealing enough with hardware that they said a robotics degree was a good idea for that because they were doing that interface between the two. When we pitched the robotics program to the university at large, one of the things I emphasized was I wanted this program to be scalable in such a way that if you got the skills from here, you could form what I call the next garage company. Most companies, tech companies, started in a garage where they're like, okay, let's throw this hardware together. Look at this cool thing that we built. I mean, Google did it. HP, Hewlett-Packard did it. Microsoft did it. Apple computers started off in a garage. They had the skill sets needed to build upon. And I wanted to give my students that skill set and the ability to do the entrepreneurial thing if they wanted to go that route. But that being said, there is a company, now I have not placed a student here, but there's a company in Vermont, which is right across the water from us, about, well, it's less than 60 miles as you drive, but you'd have to go out and around because the lake's in between. But if you get to Burlington, Vermont, there is a company that builds underwater rovers. They build those submarine things that go underwater and map out what's going on. I keep hoping one of my students gets a job there because I want to just be able to say, hey, look, you could get a job doing underwater rovers. but we talked to them and they said there's no reason why it couldn't happen with the right student, with the right skill sets, whatever they're trying to build up. So yes, you can do something with an undergraduate degree. But that's why it was very important when we had outside people come in before we started the program. One was from Purdue University, and he was more focused on the hardware aspect of our degree. He was a mechanical engineer who was in robotics. And then we had a professor come in from University of Minnesota. She was in the computer science department, once again dealing with the software side of robotics. So we had two people come in, industry experts, academic experts, I suppose. And we said, okay, here is our program as it stands on paper. If we deliver what we have here, would our students, A, be able to find a job, and B, would they be accepted into graduate schools with this background? Mm-hmm. And both unanimously said yes. We were missing one piece for the software person, and we added that Ross that you saw, she believes in Ross quite a bit. She's like, you need to have some kind of Ross exposure in your undergraduate. So we took the plunge and tried to do a challenge with Ross. Maybe not the smartest idea. I'm going to scale that back a little bit because Ross is actually pretty difficult, which is now I see why she said you need to expose your undergraduates to it, though, because it is such a broad thing that if they go to industry and they're asking for Ross, they're not going to be able to pick it up fast enough in industry. So we had to give them that skill set in-house. But yeah, so you can get a job with it. My previous students who got their degrees in physics and in computer science, because it's only 2 years old. I've had other people on the Rover, that was 4 years ago. We were piloting some of the robotics stuff, and that's why I put Rover there, because it was one of the ways the university showed that we wanted to do robotics. They both parlayed that experience into jobs. Matter of fact, Jordan was about to become chief technical officer for a company that designs the blades that go into turbo engines for doing airlines. So they design the blades that spin in those jet engines, and he parlayed the fact of what he did with Rover into a beginning job there and worked his way up through the company quickly. He was the one that came up with the rubber bands idea. Really, really brilliant guy. And so he worked his way up to chief technical officer in 3 years. And so he just right through. But once again, they had the skill set that the employer was looking at.
Yeah.
That's the big thing, is when you come here, work on building your skill sets and write them down. Put them on your resume, because if you're going to be looking for a job when you first get right out of college, those skill sets are everything. Employers are starting to see that the degree, while it's important because it shows that you know how to learn, the degree basically just tells you how to speak the language of wherever you're going.
Yeah.
And if you have skills, though, that's the things so I have two resumes. I have my teaching resume and I have I'm going back into industry resume. They're separate. My going back into industry resume has a paragraph about this big on my piece of paper of all the skills I have right up front. Like you have my name. Here's my skills. Yes, I have a PhD. That's basically the way it goes. Because they're going to say, I have a background in metrology, how to measure stuff. That's where I come from. So they'll see, I have interferometry. I'm green belt certified. That means I know statistics. I have all these things, and they're right there in the front. And that's how employers look at me now when I send out things. I still get emails from headhunters. Oh, we're looking for somebody with interferometry experience. We came across your resume. Are you interested in coming back to industry? So that's what's important. Get those skill sets and write them down on your resume when you're ready to go forward.
That's good advice. Absolutely. Everyone has a degree, but what skills do you really have?
Last question that I had is what are the areas of specialization in post-graduation that are more popular or upcoming in the field of robotics?
Okay, so I'm going to tell you my 4 favorites, and there's a ton of them otherwise.
Yeah.
One of the side is biorobotics. So they're looking at how do you either emulate biological systems or how you interface with biological systems. Okay. So the interface with biological systems could be done on a way of helping handicapped individuals interact with their environment, all the way to how to augment humanity. So I go back to movies, because a lot of times movies are what inspire people to do the next technological things. They say, oh, that's really cool to see in the movie. Let me see if I can do that. if you remember back in Aliens, I'll pull out one of these classic horror stories. There was a person in an exosuit, but it was a very open exosuit, so they could use their arms to grab packages and move them around that were heavier than what they could have normally done. That type of stuff is done. Matter of fact, I've had a student who used fishing line. If you apply a current across fishing line and heat it, it actually shrinks, and it's stronger than your muscle. So you can build artificial muscles that react on this heat and pick up things that way. The negative to it is it cools down slower than your muscle. So while you can grab something, releasing it takes a while. Yeah. And so it's not as practical yet. We're still working on that. So bio-robotics is really cool. Right now, if you wanted a job without breaking a sweat, if you learn how to do autonomous driving, those jobs, people are they're gone. Carnegie Mellon used to have the best robotics group outside of MIT in the world, in my opinion. Okay, they were concentrated right there in Carnegie Mellon in Pittsburgh, Pennsylvania. They lost 2/3 of the robotics department because companies like Tesla, Google, all these big companies came in and said, we'll offer you lots more money to keep doing your research, and you won't have to teach. Come over here and do your research for us. I'm like, okay. And now that's with graduate degrees, but even with undergraduate degrees, if you show that you have autonomous driving skill sets, you can get a job. Another one is home automation, and not home automation as in the thermostat idea. This is the one that I see when I look at the future, where there's going to be the largest growth in robotics. If you can come up with ways for people to age in place, in other words, we don't have to have nursing homes, you don't have to have a family, the family unit doesn't have to keep building around aging parents that can't necessarily help themselves anymore. If there's ways that you can automate robotics so they can stay at home and be in that environment they want to be in, but be able to have somebody cook for them, have somebody help clean the place, help somebody move them around, give them a shower. This is where robotics is going. It's not there yet. I told my students, if you can come up with a robot that fry an egg, you've changed the world. And they laugh at me. And then I tell them the scenario. Well, what happens if your grandparent is in their 80s and you're about to put them in a nursing home because they don't feed themselves because you're worried about them using the stove, but you could make a robot that could do that for them. Then that person could stay at home. And they're much more happy to be in that environment versus going someplace like a nursing home or an assisted care facility. And then the last piece that I would say in robotics is AI and looking at artificial intelligence, which is a lot of times a computer science field. But how does that AI interact with hardware? That part is still being developed. Because the way AI works right now, the reason why I can learn so well is it processes the same job over and over 1 billion times. And it comes up to itself with a model of how that job works. In real life, you can't do that. I can't give a robot a tennis racket and say, do this 1 billion times until you figure out how to play tennis. It would take too long. It gets rid of the advantage you have. But there are places where you could start, like maybe it watches a human play tennis and says, okay, I understand now how a racket kind of works, and then takes a model and starts putting this whole thing together such that then it can run its billions of ideas, put it in the real world, see how it works, run 1 billion more, put it in the real world, see if it works. I'm actually, part of my research that I'm trying to do myself is in this very field, where we're taking a robot. There's a thing called zombie tag that kids play around here, where one person is it. Everybody's running around. As soon as you tag the next person, you both are it. And you go after the next person. And then 3 people are it, and so on and so forth. It spreads. And what we're trying to do is figure out how an AI could be programmed as individual, working together in such a swarm environment. So that's another keyword. Totally forgot the keyword. Swarm robotics. So there's a lot of things in swarm robotics and taking a look at that. Because swarm, if you have a bunch of little robots, you can do a lot of really cool things. So there's people looking at that idea. Because if you have all the information, the other thing is synthesizing all the information. Because you have tons of robots doing different tasks, or even just sensing different things in the environment. If you have an artificial intelligence over the top of it, looking at all that data, what you can do with that is crazy. So those are the places that I know of. There's so many more. It's such a diverse field. I was telling one of my students who was looking at graduate school, not the one that's going, but the one that's going to looking at graduate schools now. I said, here's the thing. Google robots and keep going, like even to Reddit. Find cool things about robots there. And then go ahead and for graduate school, Google the cool thing you like and say graduate school. You're going to find there's some professor out there doing that thing.
Yeah.
And so, yeah, if I was talking to any students, like, what do you think would be cool? The idea with the robotic arm, my student likes Iron Man, the Marvel superhero Iron Man, and he wanted to be Tony Stark. That was his thing. He's like, I want to be the dude that makes the armor. Mm-hmm. I'm like, that's so cool. All right, so this is the field you want to go. So Colorado School of Mines, University of Colorado, which is where you got accepted to, is one of the top 10 graduate schools in the country, and one of their specialties is adaptive robotics. How do you build robotics that helps humans do things? So it's a natural dovetail. And what's great is I think one of the reasons why he got into that school, besides the fact he's a really smart guy, he's already done some of this stuff. And they saw that. And they're like, okay, yeah, please come. So yeah, so those would be 4. And there's so many.
Well,
but I think even these 4 makes a lot of sense. Even when you were sharing about one of the areas of specialization, I actually remembered a movie where a robot was helping out an old person, and how he makes his life more easier. So it's already there. The ideas are already there. So I think it's for the students to now actually make it a reality.
And that's where the garage company comes, right? Yeah. Come up with your neat niche and go with it. You could be $1 billion company if you want to go out and do it, if you could find that niche. Yeah. And so
and I think it's important too for students, like you had mentioned earlier, Dr. Walters, how your life path has all these caveats, right? And you change. Mine does too. And I ended up in Plattsburgh, New York somehow, and but it's like a lot of students that I talk to, they say like, well, I don't know what I want to do, and I say, well, of course you don't know what to do. You're 18, and not only maybe you'll make a decision on what you want to do, but chances are that's going to change. Yeah. Right. And like what you just said about all of the after your undergraduate opportunity, there are numerous opportunities in the workforce. Right. But then there's also opportunities in graduate schools. I mean, you listed 4 for further areas, but who knows how many more there actually are. Right. And so that, it's okay in the beginning if you don't know exactly which way you're going, because that's actually normal in my experience, right? And it's working with professors and your peers in the classroom and learning what it is you like and which direction that's going to come. And eventually that will all come. Don't put this pressure on yourself that you have to solve the world's problems and have an answer for everything when you're a freshman in college. It doesn't work that way.
I love telling the story of, because one of the things that we do have at Plattsburgh is what we call a BAMST, where you can get your Bachelor's of Arts in Physics and a Master's of Teaching, because in New York State, you have to have a master's degree to teach in New York State. And one of the things I point out to the students that I advise for that program is the great thing is they get you in the classroom in your sophomore, junior year. You're not teaching, but you're in the classroom, so you see what is behind the curtain. You know what the teachers do in the classroom, but you don't see all the stuff they have to do outside the classroom to prepare for those things that are in the classroom. My wife, I use her as an example. She loves this. My wife decided she was going to get her master's in teaching. She didn't get into a classroom till her second to last semester in her master's program. Found out she hated it. A little late to find out you hate it when you're in your second year, second to last semester.
Right.
She finished her degree because, once again, you've started that. Now she's going to finish it. And she's used it for other reasons. but she's never ever been an elementary school teacher, nor will she ever be an elementary school teacher. That is not her deal. She found out it was a horrible idea. So the cool thing about Plattsburgh, once again, come in, try the stuff.
Yeah.
We have clubs, which I didn't even mention. We have clubs. We have a physics club, which is almost like an engineering club / maker club. We go out and build stuff. We built trebuchets to chuck pumpkins. So to throw pumpkins as far as we can. It's a medieval siege engine. It's small. We don't make one the size of a house. But we make these little siege engines and throw pumpkins hundreds of yards or hundreds of meters just for the fun of it. Yeah. We have an electric car that students have tried to build. It's still in the process of being built. I'm going to start a new system next semester where we're going to try the entrepreneurial spirit. I really do believe in entrepreneurial spirit. I really like getting your hands in it and doing stuff. And we're going to form a quote unquote company in the physics department. And what it's going to do is I'm going to get a bunch of students who are interested in this project, and we're going to sit there and brainstorm what are different problems in society we see, and what are some ways we can fix those problems that we could possibly build here. And we're going to start building prototypes. We're going to see through the university, we can patent things. Through the university, we can help get startups going. And I wanted to see what my students could, when I still love the fact Jordan was sitting there and came up with a rubber band iris. I mean, that just brilliant. Why not give other students the same opportunity where it's like, okay, let's talk about these problems that society's seeing. That we can look at big problems, we can look at little problems. I don't care what they are. Find it.
Yeah.
Pick something. And I told you about the fundamentals of engineering design. You will be doing that in fundamentals of engineering design. That is part of the course. But it's an artificial 15 weeks, right? You start it and you try to get to the end of it by the end of the 15 weeks. This one I'm proposing is going to be open. It's going to take years. So it might be that you graduate and you're gone by the time the product that you were working on gets done. So be it. But you were part of the process. You could see how that thing worked in that section that you were in.
Yeah,
and I
awesome.
want to give that experience to our students.
That's awesome. Well, I'm looking at 10:30.
Oh,
I think you have a class in 30 minutes, and I have more emails than any sane person should have.
And I need to go and cook up my dinner.
Oh, that sounds great. I'll be right there.
I talk too much. I know this.
Oh, it's fascinating.
It was a pleasure listening to you talking so passionately about subject on robotics. It really increased my knowledge about this particular field, and I'm sure I'll be able to pass it on to the students I interact with.
Excellent.
Great.
That's pleasure.
Great. I will send you, Bina and Tulsi, I'll send you a video of this today, and I'll send you the PPT that we had as well, so you can share with students and get references and whatever.
You will be sending me the recording link as well, right?
Yeah, I'll send you the recording as well.
Yeah.
Yep, no problem.
And thanks, Peter, so much for organizing this.
Yes,
yep, this is what I do. This is what I do. I do it every day. It's quite fun, actually, but I don't get to talk. I don't get to listen to robotics stuff every day. I mean, that's pretty fascinating. And actually, before we go, Dr. Walters, I would love to see some of this stuff. If it's ever being done on campus, like drop me a line sometime. I would love to go and see this process. It's fascinating. But
when we get to the point where we're demonstrating, I'll have people come in.
Yeah, that would be really cool. That'd be really cool.
My goal this year was to get projects so the intermediate robotics ones where they're doing those 2 projects. My goal was something that was YouTubeable. I wanted something I could actually put up on the web, say, look, here's what the robot's doing, and have my students actually talk about it.
We'll use that as promotional stuff for us as well. Like that would be really cool. But all right.
In our school, we have many young children of grade 5, 6, 4. They are so enthusiastic about this particular topic about robotics. So we do have these workshops that are conducted throughout the schooling time where students are working with their kids, robotic kids, and creating small robots. So it is something that is very fascinating for children.
Wow, that's cool. Yeah.
Yeah, it is. Even I didn't know much about robotics back then. Actually, even my way was something like this. I was actually wanted to become a computer science engineer, and then this COVID thing just changed my opinion. I just thought, why to sit on computer 24 hours? So I just thought of changing something. Then I went to cyber security. There I heard this word Internet of Things, which really fascinated me. So I was just going through this Internet of Things, and then when you were saying about Arduino, Raspberry Pi, I was just connecting those things. Yeah, I have heard these things in
Yeah,
Internet of Things.
that's
Yeah,
great. Awesome.
It's
Best
so
of
it was
cool.
luck.
really good.
Best of luck to you.
Thank you. You too. And
Thank
hopefully see
you.
you.
Thank you.
Yeah, Tulsi, we will see you here in Plattsburgh very soon, I hope.
That'd be awesome.
And
Yeah,
Bina, let's stay in touch. And anytime we can collaborate, I'm all for it. So,
Definitely. Thank you
okay,
so much.
you're welcome.
Bye.
Thank
Have a
you.
good
Take
evening.
care.
Bye.
Bye
have a
bye.
good
Bye.
day.
Bye.
Bye. Sir.